Hello and welcome back to Pandemic Playground. Today, we have another episode of Space Engineers Experiments. And this one might be a rather pointless experiment, but it is going to be dealing with drilling rigs. So when we talk about drilling rigs, I mean the drilling rigs that I normally use. And that is one of two basic styles that I normally do use, and one is the Rotor System drilling rig that spins around in circles and digs down slowly on a vertical basis. And with the addition of the Hinge, we started to use this design a little bit more to sway back and forth using timing blocks, with the same concept of vertical pistons. So the test here really is, one, how much materials does it really take to build these things when it's fairly equal? And two, which one is more efficient in terms of gathering material? I know a third experiment would probably be to see which one is quicker to drill stuff and gather stone and materials, but I didn't want to test that because you could tinker a lot with the piston speeds, rotor speeds, hinge speed to really dive deep in which one goes faster. But I didn't really want to do that because its speed is not the issue, especially when you make drilling rigs like this, where you're not really here to really sit there and watch it go down. So it's pretty much trying to figure out which system is a little bit more efficient at gathering stone or materials based on their abilities of either rotating or hinging at an angle. And of course, we have a base control with the same types of materials and the same amount of drills to really see how much this one gathers. So to start the experiment, what I did was create the two drill systems that I normally use. This hinge system I've been using more often, and because of the hinge block that's new to us. The hinge one uses 7 drills, the rotor uses 7 drills, and the control also uses 7 drills, so that there's no variations in them at all. The pistons, we have 4 each going downwards, and it's all connected through connector junctions or conveyor junctions into their individual large cargo storages. Of course, there's an issue with this because the flooring is different, as you see here. Some of them might be a little higher than the rest, so give or take, they might be gathering a little bit less or more depending on the height of where they are currently at. So we just gotta minus a few in terms of collections. So to begin the experiment, we're gonna have to put the drills on and then put the pistons on as well. But before we begin, let me show you a quick time lapse of the build. Generally, when we talk about how much it takes to build these things, if they're equivalent, the only big difference is actually going to be the materials used for a drill and rotor. So the advanced rotor takes 5 steel plates, 2 computers, 4 motors, 4 large steel tubes, 10 construction components, 10 steel plates, against the hinge block, which takes 6 steel plates, 2 computers, 4 motors, 4 large steel tubes, 10 construction components, and 10 steel plate. So it takes 1 more steel plate as a difference. So that is not significant whatsoever. However, the biggest difference is the timing block. Because we want the system to sway back and forth, we need to build at least 2 timing blocks, which is just say times 2 of what is needed for a timer block, which is 10 construction components, 5 computers, 20 more construction components, and 6 interior plates. So obviously, it takes a little more to build this type of rig, the hinge block rig, versus the rotor rig, because it doesn't need these timing blocks. Yes, they're there, but they're not going to be in use. And of course, the most efficient way is going to be the control. But we already know this is generally not going to gather a lot of material whatsoever anyways, because it has less surface space to cover when we drill. Alright, so let's begin. So we're going to turn on the drill first, and now we're going to put on the pistons. So the pistons, just to make it an experimental control, we are doing all pistons at a velocity of or 0.02. Why? Because we want to make it as slow as possible so that it can start gathering the materials slowly. So as you can imagine, if we were to force it to go down really quickly, what's going to happen? Things are going to either damage, blow up, and make things not work. Or you're really not going to gather the most amount of stone or anything by just drilling quickly. By going as slow as possible, even if we were to do an experiment with the same exact basic control rig, if you go slow rather than fast, you're technically still going to get more over a slower piston downwards system, because it's going to slowly gather more around the drill rather than going quickly down into the drill. So that's a little bit of a tip for you guys if you are going to start drilling downwards with a simple rig like this as well. Alright, so with the drills on, I'm going to hit the piston button, which is going to make the drills go down at 0.02. And of course, we're not going to sit here and watch them go down at that slowly. We're going to put on that time lapse so you can see the drilling. And then we'll come back and see check on the storage to see how much each one has collected. Alright, so that took about 10 minutes of drilling basically, and let's take a quick look. Alright, so the hinge block drilling rig kind of digged out a very square rectangular shape on the ground, which looks interesting. Since it does this square rectangular shape, it kind of saves us from making a lot of drills. So if we were talking about equivalency of how many drills versus not having the hinge block, we'd probably have to make 2 more layers left to right, so that will be a total of 4 layers times 7 drills across. So that's about 28 additional drills that we would need. So the hinge block would kind of save us from that, which is very nice. So I kept them running. I don't know how much is collected just yet, but we'll look at that together in a few moments. But if we want to look at the rotor system, this is pretty much the old-fashioned type of rotor system or drilling rig that I used to create to save on drills. And definitely this one is a circular pattern. It's always going to be a circular pattern, to be honest. Or if you wanted to, you can make it more of a more line pattern. So if you were to put the rotor system not going circular horizontally, but circular vertically, that's a possibility. And it's going to look like a Ferris wheel, which is kind of pointless in some ways, but it can cover a lot of space that way. So that's something to look into as well. But this is the normal rigs that I normally build for drilling. And this one, again, it just makes a circular rig basically. And it also saves from us doing like a square one as well. So this one, probably same as this one, will save a little bit more of drills too. And lastly, without control, we just have a bit of a rectangular drill straight down. And that's the most basic of drills you could possibly make. And it's not much to it, to be honest. It just goes down, gather as much as it can, and that's it. So that's pretty cool for shapes wise. But let's check in to see how much these things really gather. So before we do that, let's just reverse the drills. Alright, so they're off, so they're not gathering any more material. So we can also tell the pistons to come back. Alright, so we stopped everything, and now we can check on, for one thing, is how much actual drills we can really save. So I stopped them, turned them to their default settings so that it faces the right way. So we said about 28 drills was the magic number. So if we were to say and add 2 layers on this side, 2 layers on this side, we will create the same exact shape as we had going straight down, which, yeah, so it looks about right. Maybe even one additional layer, to be honest, but it saves us that many drills, to be honest. And for the rotor system, if we were to add more to this one, alright, so this one's not going to be a perfect math to it, to be honest, but if I create it to kind of make like a circle, we're really saving only about, oh yeah, 5, 6, 7, 8, 16 total drills. I mean, yeah, you can say, yeah, maybe one here. So add that 4, so that's about 20 drills versus the 28 drills. That's a bit of a difference in terms of, you know, how much the shape is and how much drills we're using. It's not the perfect situation or perfect math. Let's just say it's this kind of shape where it's not overboarding the, you know, the shape itself. This would technically be saving 18 drills versus saving 28 drills. So in that case, then the hinge block's a little bit more worth it in terms of the shape gathering, if you can kind of say that, basically. And of course, this one is just a line. If we added more to it, it'll look pretty much like the same thing we have on the hinge block. But if we were to say put about, you know, the 28 here, it's gonna look exactly the same as what we had for the hinge block. But if you wanted to do a circular one, then it would, you know, you just plop on probably 18 of these bad boys here instead. So that is what it would probably look like. So let's now go dive deep into the cargo storage. All right, so we're gonna look at the large cargo containers first. We're gonna ignore the hinge and rotor system ones here. So we're just gonna hide the empty ones as you see here, and then we're gonna look at all the large cargo containers without the rotor or hinge name. So large cargo container 21 is completely filled, and large cargo 22, so it looks like it only filled up approximately 2 of the large cargo containers, and this one, it filled up 1.5 cargo containers. So we have 1,140k of stone plus 666k of stone, which is odd number, but okay. Well, technically it's an even number to be honest. Just a weird number to have. So that is a total of 1806k of stone gathered for the regular drilling rig. So now let's take a look at the next one, which is the rotor system. So the rotor cargo container. So let's look a look at that. Hit rotor large cargo, and we'll hide the empty ones and see what we have. Already we can see it is more than our control. So we filled up 1, 2, 3, 4, and probably a little less than a quarter of cargo containers. So we have 4,780k worth of stone collected. So that is a significant difference from our initial, or from our control, as you can see. So that is more than doubled in that sense. Now let's take a look at the hinge block system. So now if we look at the hinge block cargo containers, we have a total of 5 containers filled, except 1 container not completely filled, but filled at 927k of stone. So that's 4 filled containers and an additional container that's nearly filled, which will give us a total of 5,487k of stone. So that is a bit of a difference between the rotor drilling rig, which is ideal. So that means the hinge block style gathers a little bit better than the rotating style of the rotor drilling rig that I pretty much create. So that pretty much concludes it, and that's gonna say basically this one is more efficient at gathering material, But of course, again, it takes 2 more timing blocks and 1 additional steel plate versus the rotor system that I normally build. And of course, there are some variations. Again, the height is one variation that kind of defeats the, or kind of changes the variables of the experiment. But this one still gathered a lot more than the rotor system, so that we can tell this one works a little bit better. And the other variation is, basically on the ground, it very depends on, what's readily available in terms of stone amount. So the top layer is a lot less, as you normally know. So the grass and the dirt does give us a lot less stone versus what's down here, which is like what they think call it bedrock or something like that, which pretty much gives it a lot more stone in terms of gathering that over there. But look, if we're looking at the layers, they're about the same, so that doesn't really change significantly. But having the hinge block on the highest end of the floor and being able to gather not a really big significant amount, but around 700k of stone difference, this one of course is my new favorite. I always, once we had the hinge block, I started building a swaying system in terms of a drilling rig, and it's perfect because it does create this nice little square or rectangular shape that I like in terms of like building a tunnel or building a hole if you want to build like an underground base or something similar to that. But if you want something more of a silo circular type of base or system or tunnel, definitely go with this circular rotor rig itself. So this one I used to like because it gathered a lot more stone than building a whole bunch of drills on a boxy way, and it was able to gather a lot more, of course, compared to control. But now since the hinge blocks came out, it was able to gather a lot more, and this of course has been my new favorite ever since this wonderful hinge block has come available to us. Of course, if you think about it, you can actually combine the two. So how would you do that? Well, let's see. Alright, so if we really wanted to increase the efficiency of this, we can eventually put the rotor system, as I mentioned before, combined with the hinge block. And then it's gonna look something like this, which is a little crazy. It looks kind of like an amusement park ride, to be honest. And if we put a chair there, it probably would look exactly like a amusement park ride. But this here will probably gather in a circular motion, and of course a little more efficient than both and all the rigs that we have combined. So let's turn it on, the pistons going down, to see what that shape's gonna look like in terms of breaking down the rest of this shape here. Alright, so as you can see, with the combination of the rotor and the hinge block, it creates a weird looking shape. It's becoming more circular than square, so it's probably not the most ideal thing. And of course, if you saw in the time lapse, it was colliding against the walls and it was causing little bits of issues here and there. So you're gonna see a lot of like little jagged edges and everything like that. But on the very bottom, you'll see pretty much like a scoop or circular type of drilling in this hole. So we definitely need to tinker around with the velocity of the rotor and the hinge block to actually make this work. But in this experiment that I wanted to try, definitely go with the hinge block style drilling system over just the plain rotor system that we previously only had. And lastly, to be honest, if you really need to save on parts, of course you don't need to build big drilling machines like this. you can just build them and convert them to small grid drills instead of the large grid drills. So each one, the rotor and also the hinge block, can allow for that, so you can save on a lot more materials. So of course, that might be another experiment to see how much we can really save on those, to be honest, but we'll look at that at a different date because I really wanted to compare a rotor system that I usually used back then versus what I'm using now, which one is more efficient, and of course, hinge block wins. Alright, so that's going to be it for today's experiment. Don and I have been looking into other experiments to work on, and those are coming up in the future. So stay tuned for that, and of course hit that notification bell to be alerted of upcoming videos. Also, don't forget to subscribe to Pandemic Playground. Leave us some comments and let us know if there's any other experiments that you may want to see but don't have the time to do it yourself. And of course, hit that thumbs up and like the video. Thank you very much for watching. I'll see you guys next time. Bye.